This first project will introduce you to the production process and have you use either TapToons or iStop Motion to create a simple animation that demonstrates squash and stretch and timing. Perhaps you are already familiar with the classic bouncing ball animation. It is a classic because it demonstrates the basic patterns of movement. Those are squash and stretch and timing. The squash and stretch effect is shown by having the ball round at the top of the bouncing arc, becoming stretched as it drops to earth, squashed when it makes contact with earth, stretched again as it bounces off the earth, and arriving as a circle at the top of the bounce. The bouncing ball animation, as in life, we must remember that gravity is always pulling down on the objects and characters. That is why we must keep in mind squashing and stretching as we animate a scene. It keeps the characters looking more alive and fluid. When using squash and stretch, there is an issue of volume control. Squash and stretch is not the way an accordion works. Due to its construction, when an accordion is stretched, the volume of the shape expands. With organic characters, the volume must be maintained. No matter what you do to the character, the illusion must be maintained that the character does not inflate. Think of a water balloon. No matter what squash and stretch distortion happens to it, the amount of water inside does not change. Our next topic is timing. As they say, timing is everything. This is especially true in animation. The more drawings that are used between individual object or character positions, the slower the action. Inversely, the fewer the drawings between individual object and character positions equals faster action. You can go back and check the bouncing ball animation. At the top of the arc, the ball is moving slower, hence more drawings. When it is plunging to the earth, less drawings. It is the use of timing that creates entertaining animation. Not all the action is at the same speed. Timing is also about how many frames are used for a particular action. You can experiment with this, but in most cases each drawing will be in the film for 2 consecutive frames. This is called animating on twos. For timing actions, reference the old silent movie comedians. They were masters at it. Just a reminder, the closer together the drawings are, the slower the object moves, and vice versa. To keep track of all the animation bits and pieces that might occur in each frame of a scene, a timing sheet, called an exposure sheet or X sheet, is used. We will get into X sheets in more detail in a subsequent class. But for now, just understand that some of them use the classic 24 frames per second of film, and some use 30 frames per second for digital media. Either way, the X sheet is the blueprint for the production. Without X sheets, no one but the animator would know what was going on in the scene. Not using X sheets is not a professional production approach to creating quality films. Here are some typical timing situations you might have to create. For the first 3 bulleted items that say drawings, remember that each drawing is in the movie for 2 frames. So a 16 drawing walk cycle is actually a little over a second for film time. You'll get used to this after a few of the projects we'll be doing. I know I say that most drawings are on the screen for 2 frames. However, this rule is broken for certain timing situations. Note the hand reaching for the pencil is beginning on 2 frames for each drawing. But when the hand grabs the pencil, that hand is held for 4 to 6 frames. Then the hand moves back along at 2 frames per drawing. Now we are on to project 1. We are going to reproduce the bouncing ball animation. The overall objective of this first project is to get you acquainted with the production process, including the pencil test software. Go to the assignments section for this online class for week 1 and download the project 1 layout. All you'll have to do is trace the balls on the layout. Each ball drawing is on a separate piece of paper. The final animation will be on 2s. That is, each drawing will be in the film for 2 frames. I suggest you refer to the PowerPoint presentation called Process.